Hi, this is Josh once again with a support video for SAT lesson 23, pie charts and box and whisker, questions 1 to 10. Question 1, what is the mode of the following data? When you have a data array like this, it can be frustrating unless you just block the data off in manageable steps. So here, when I tally the block of data, since there's a lot of it, let's do the first row together. And then as you can see, based on the tally, I'm just coding the first half of the string and then the second half of the data. And then I make sure that I check off the cells as I go through the data before going on to the next row. The next row also has the same number of data points. And after tallying them, that's the distribution. And the third row, and so on. So now that the data is sorted, it's much easier to just count up the tallies, and we can see that the mode of this data array was 3. The correct answer is B. Question 2. What is the difference between the median and mode of the following test scores? Well, again, this is a long string of data with decimal points. So in order to arrange them from least to greatest, I would block them off in groups of 3. Seeing that there are 9 data points, the first 3 of the lower data are 3.9, 4.7, and 5.2. And then the middle data is 6.1, 7.5, and 8.2. And the upper data is 8.2, 9.7, and 10.3. The median is the data point that is the 5th element of this set of 9, and it's 7.5. And there's only one mode at 8.2. None of the other data values are repeated. The difference between the median and mode, therefore, is 0.7, and the correct answer was C. Question 3. What is the average temperature for this week of data? Well, thankfully, whoever wrote this problem was in a place where it was a constant temperature in the 70s. We'll sum all the data and divide by the number of days. It looks like a week is a full week of 7 days to get the average. One shortcut is because all the temperatures are in the 70s, just do 70 times 7 for 490, and then separately add the ones digits. This helps you sort the data much faster. Also, there are some tricks to counting the ones. You can just find any two digits that add up to 10. So for example, just block together 7 and 3 and 4 and 6, and you have 20, and then just add the remainders, and you'll have 28. As another shortcut, since it's 7 days of data, 490 divided by 7 is 70, plus 28 divided by 7 is 70, plus 4, 74. These are shortcuts which make for very good time savers on the SAT. Finally, if you do have extra time, you want to check it relative to a utopian week where every day is 74 degrees. So here I wrote down pretending that it's 74 degrees for all 7 days. Then below, taking the deviations from that average, we have 0, 3, -1, 2, -2, 1, and 3, which gives us a zero sum. So we know we have the right average by checking these deviations from the mean. The correct answer was D, 74. Question 4, what is the range of these baby shoe sizes in European sizes? Well, you might think your child has massively large feet, but 16 is a small baby size shoe and 28 is a mid-sized shoe for these babies. And those were the largest elements in the set. The range is the greatest minus the least, which would be a range of 12 different baby shoe sizes. The correct answer was D, 12. Question 5, what is the percentage of data that is at most 2? Well, again, as a basic computer science job, if you work for a professor or work for a company where you're a data sorter, there's a long string of data here. So again, by using blocks of 5, it really helps you organize and do the math properly without making errors. So by blocking the data off into these blocks of 5 in alternating colors, we can see that there are 25 data points, no more, no less. And now we're searching for values that are 0, 1, or 2, because these are single-digit values on this data table. In the first block, there are 2 such elements. In the second block, there are no elements that are 0, 1, and 2. In the third block, there's 1, and so on. Tallying them all up, there are 7 data points that are 2 or less out of 25 total. Scale that up by 4, and that's 28 over 100, which is 28%, and the correct answer is B. Question 6. What fraction of the rectangular prisms have a volume of less than 240? Well, this is some weird type architect's table with 8 different designs, as you can see, and they don't seem to be arranged for you, whatever these rectangle prisms represent. However, as a shortcut, what you can do is, knowing that the volume is length, width times height, you can take 2 of the 3 measurements and multiply them to make the math easier. If you look at the way I listed all 8 of these rectangular prisms, if I saw that there was a decimal, I would multiply it by 2 or scale it up to try and reach a whole number to make the product easier. Again, I can do this without a calculator. For example, for prism number 1, 8.5 times 11 times 2 is 11 times 17. Well, 11 times 17 is the same as 10 times 17 plus 17, which is 170 plus 17 is 187. 2 and 3 are pretty self-explanatory. But for prism number 4, if we have 9 times 7 times 2.5, well, 9 times 7 is the whole number 63 times 2.5. To save time, I'll compare that to 63 times 3, which is 189. So we're still under the lower bound, the bound of 240. So 4 is also on our good list. Question prisms 5 and 5 is certainly less than 240. Prism 6 is much more. Here I did 5 times 12 to get the number that ends in 060. Prism number 7, like prism number 4, I have 18 times 12. Well, that's not easy to do, but if I compare that to 20 times 12 is 240, certainly whatever that product is, it's less than 240, and we're within the requirement for the volume being less than 240. Similarly with number 8 and done. So doing those with those little speed tricks, you'll see that 6 of the 8 prisms satisfy the architect's condition that the volume is less than 240. The correct answer was C. Question 7, what percentage of the data is less than 4, greater than 7? All right, so 2 conditions of tolerance here. And we have 20 data points, which are nicely shaded for us, like spreadsheet data. Notice that the first 5 columns are white, and the next block of 5 is gray, and so on, and they alternate. So using the blocks of 5 data idea, we can see, so going through them 5 at a time, you'll make very few errors. And that there are 6 data in the set that are less than 4, greater than 7, which is 3 out of 10 or 30%. Okay, there's no, even if it's the calculator section, there's no need to use the calculator to code the data yourself. It's much faster to block them off in groups of 5 and tally them up quickly. Question number 8. Right, for the following problems, use the pie charts for the survey of favorite gym activities, comparing Einstein High School and Fort Wadsworth Academy. Well, question 8 is, what's the most popular gym exercise at Einstein, which is the school on the left? For that pie chart, 7 is the largest slice, which is hard to see, but there is a key here that says that's 25% of the student population, like lead lifts, and the correct answer is B. Question 9 is a comparison question, comparing how many more students like burpees at Fort Wadsworth than those who like sit-ups at Einstein High School. And we can see that that's 25% at Fort Wadsworth, which is 300 students, and at Einstein, 15% of 1,600, which is 240 students, for a difference of 60 more students at Fort Wadsworth. For the last question in this introductory set, we have, what is the total number of students in both schools combined who liked exercises with the word ups in it? Here you can see that the activities of push-ups and sit-ups both contain that English phrasing. So just be careful as you look through the list, and you can see that for Einstein, that's 30% of that student population, compared to Fort Wadsworth, which is a smaller school, 22%, for a grand total of 480 plus 264, or 744 students total. And the correct answer was A. I hope that this video is useful to you in your preparation for your upcoming SAT. Thank you for watching my video.